Let's talk about quadratic number patterns. Now this is a little bit different, but it's defined by having a constant second difference. Okay, so not a constant first difference, a constant second difference. Okay, an example, will be as follows. Let's say 3, 5, 8, 12, 17. Let's look at that. So our first difference will be 2 between those two terms. Over here it was 3, over here it was 4, over there it was 5. Okay, so this was the first differences. Now let's look at the second difference. 3 minus 2 is 1, 4 minus 3 is 1, 5 minus 4 is 1. Can you see that these are the same? The moment they are the same, then we know it's a quadratic number pattern. So that's how we're going to test for it. Okay? But first of all, I want to show you how the theoretical foundation works for this specific quadratic number pattern. And I'm going to use a lot of A, B's, and C's, but please bear with me. Okay, let's first define our equation. It's quadratic, so you will definitely recognize the following equation, right? Can you see it's just the same as any parabola? Would have been y equals ax squared plus bx plus c. Okay, now we're just using n because we are working with number patterns. N for number patterns. Okay, so now if this is true, let's quickly write out the first 4 terms in terms of a, b, and c. In other words, can you see that's an n? So n is equal to 1. So if I substitute it in, this will happen, right? Over here, n will become 2. And over here, n will become 3. And over here, n will become 4. We don't have to continue any further than this. This is just to help us work through it and to explain it better. Let's simplify each one. So T1 is equal to A plus B plus C. T2 is equal to 4A plus 2B plus C. T3 is equal to 9A plus 3B plus C. And T4 is equal to 16A plus 4B plus C. Okay, this is just setting us up for success. Okay, so our first term right over here has a value of A plus B plus C. Our second term, just to help us, I'm just going to draw a little line like that. Our second term is 4A plus 2B plus C. Our third term, 9A plus 3B plus C. Our fourth term, 16A plus 4B plus C. Okay, now remember, to get the first differences, we have to say term 2 minus term 1. Okay, so let's do that. 4A minus A, 3A. 2B minus B is B. C minus C is 0. Okay, so this is our first difference for between term 2 and term 1. Okay, between term 3 and term 2. 9a minus 4a is 5a. 3b minus 2b, b, and c minus c, 0. So this is the difference between term 3 and term 2. 16a minus 9a is 7a. 4b minus 3b is b. And c minus c is 0. So here we have our first difference. This row is the first difference. Now we want to get to our second differences. 5a minus 3a, 2a. b minus b, 0. 7a minus 5a, 2a. b minus b, 0. And this is, all of this is just to take you to 3 different equations. Remember now, we have 3 unknowns, a, b, and c. How many equations do you need to solve an equation of 3 unknowns? 3. Okay? And this is literally what we are going to do. So keep this in mind. These 3, you need to memorize these. Okay? If you're serious to know this work, memorize these equations. It's going to save you so much time. And then from there on, we'll do an example now. Okay, so the question asks of us to get the general formula for this number pattern, and the number pattern is given as 1, 7, 19, 37. And in a test you'll always see this. They give you this number pattern, they ask you what are the next 2 terms, and then you have to calculate. And then what's the general formula? And after they ask you what's the general formula, they would ask you what is the value of the 47th term or something like that, right? And then afterwards they would ask you which term has a term value of, and then they give you, that's, all of these are the typical questions that they can ask you. Then the last one has to do with a minimum and a maximum value, but we'll do that at the end of this video. Okay, so first step, you have to identify is the linear or a quadratic number pattern. Okay, so 7 minus 1 is 6, 19 minus 7 is 12, 37 minus 19, 18. So it's clearly not a linear number pattern, right? So just to show you, 12 minus 6 is 6, and 18 minus 12 is also 6. There we go. Now we've identified which type of number pattern this is. This is a quadratic number pattern. And remember, all you need to know is that 2a is equal to 6. And I get this from here, 2a. 3a plus b is also equal to 6. And a plus b plus c is equal to 1. There's your 3 equations. And you start with the bottom and you work your way up. Okay. So 2a equals 6, a equals 3. That's it. 3a plus b equals 6. So b equals 6 minus 3 times 3, because we just calculated it. So that makes b negative 3. A plus b plus c equals 1. So that makes c 1 minus a, and minus b. So it is 1 minus 3 minus a negative 3. So it's just equal to 1. Therefore, Tn equals 3n squared minus 3n plus 1. Can you see it took us about 1 minute? maybe less, 30 seconds. And this is 4 marks. 4 marks for 30 seconds, I think. Okay, now let's take a next up question. So now, based on this equation that we just got, they tell us Tn equals 1261. Which term is equal to that? Okay, so remember, we already know from our previous calculation that Tn is equal to 3n squared minus 3n plus 1. Okay, so what do? We substitute 12261 equals 3n squared minus 3n plus 1. Now we have to simplify. Okay, we've got a 0 there, that means we can factorize. So if you can factorize this one, go for it, no problem. But normally with a number this big, it would be safe to rather do your quadratic equation, right? So hopefully you still remember that one. So in this case, n would be equal to minus b plus minus square root of b squared minus 4ac. Can you see how all of the things just tie together again with mathematics? That's how it works. And now, plug and play. Minus a negative 3, remember your brackets. It just makes life easier. Negative 3 squared minus 4a, which is a 3. And c, negative 1260. Remember your negative, because that's normally where people make mistakes. Over 2 times, so this will become 3 plus minus square root of something over 6. Okay, so you have 1260 times 3 times 4 plus 9 is 15129, and its square root is 123. So this will be 3 plus minus 123 over 6. And remember, all of this is equal to n. So now we're going to get two numbers, right? So therefore, n equals, and now 3 plus 123, right, is 126 divided by 6 is 21. Or 3 minus 123 is negative 120 divided by 6. And then you get negative 20. But can you see this is a negative? A term number can never be negative. So if it's negative, you do not take it into consideration. Okay, so very important. 21 is our final answer. Okay, last thing I just want to illustrate. Remember, this is a quadratic function. So that means the function has a graph that looks something like that, or something like that. Okay, so depending on your equation, you can have a minimum value right over there, or a maximum value. So whenever they ask you to calculate which term will have a minimum value or which term will have a maximum value, the only thing we are interested in is the turning point. And remember, how did we get a turning point always? You had x equals to minus b over 2a. And at that x value, you have the turning point. If it's a minimum or maximum, doesn't matter. So in our case now, we are going to work with n being equal to minus b over 2a. So whatever the question regarding a minimum or a maximum, your strategy is, first of all, calculate the turning point by saying n equals minus b over 2a. That will give you the term number. And then from there on, substitute this term number into the equation to calculate the actual term value. That's either a max or a minimum value. And that is it. That's basically how you calculate this.